Hey, welcome to Dr. Pat TV. We're looking at domain and range today. And then we'll do piecewise functions later on, just to kind of work that. Okay, domain right here, basically it's all those x values in that. See, we talk about things in terms of ordered pairs. So as you can see right here, we kind of count those as data points. It's also called an ordered pair. And so the domain is always the first, the x value, that first number, the first element of the set. And so then that's domain. And then the second number that we have, usually like the y value in a data point, that's the range, okay? So domain are the x values, that's the input. Domain range is the output. So I'll just write that input. And range is the set of all the outputs. Okay, so when we have three data pairs right here, this x value right here, that's part of the domain. This x value here on the second point, part of the domain, and that 5 is also part of the domain. So what we're doing here with the squiggly brackets is listing all those numbers that are part of the domain, the x values of these three data points. And then the y values, take that 6, 8, and 3, put them together, and we have a second set of numbers, and that's the listing of the range. That's the listing of the y values. That's within this relationship of three data points. Okay, so just take a moment. I'm going to pause. Just take a moment and list the domain and range for this problem. Okay, hopefully you've got the same set that I have. I just basically indicated all my x values. Here's my x, here's an x, there's an x. The first number in the set, these two numbers, this coordinate pair is the x's. That's the input, that's our domain, the list of the domains. And then here's my y values, those at 7, 11, 15, and 19. I put those together as the list of my range. So that's what we got going there. That's how easy it is to identify domain and range when you have data points. Oops, there's our answer. Okay, cool. Now when we're looking at graphs and you want to know the domain, one way to look at it is look at the shadow. So when you're doing domain, put your spotlight right up here. Put that spotlight right up there. Let the light shine down. When the light shines directly down onto the x-axis, the shadow that it makes is the domain. So the domain is going from 3 to 12, and because these are solid endpoints, this domain includes the 3 and the 12. That's why I got greater than or equal to signs. If you're doing it in notation format, you would probably write a 3, 12. That's not a data point. This is an interval of x's, so it's kind of confusing, but that's what we do. Okay, so I'm starting at 3, ending at 12, and I'm using the square brackets to include those endpoints. Okay, so domain is on a graph, make a shadow. It's the listing of all the x's that are used to make that graph. So when we do range, you're making your shadow, you go in the other direction. This time my light's over here, shining in this way. I'm shining towards the y-axis. That's my range. The range is the y values. And the shadow that I make looks like we're going from 6 to 12. And so that's my range. And once again, because those endpoints are included, that's why we're included the 6 and the 12. Okay, so that's kind of what we're looking for. And when you're making these inequalities, also we could write it as our interval notation. That would be 6, 12. And we always put the lower number here on the left, the lower number, and then the higher number on the right hand side. The reason we do that is because it matches how we do our number lines. Our number lines are always set up with the lower numbers on the left side and then the higher numbers on the right. So our interval notation using the square brackets here, basically what we're doing is we're following the same pattern. So just a reminder of that. Okay, and now let's take a look at this problem right here. Okay, so I'm looking at my domain. My domain is the x values. So kind of envision, once again, I'm envisioning kind of my light up here, the shadow. Looks like my farthest left x value is 0, so I'm going to start at 0. And my farthest right x value is 4. again, because domain is the x value, so that's a left-right kind of thing on a graph. And I'm looking at endpoints. They're included, so I'm going to do square brackets. And also, I'm including everybody because it's a nice continuous graph. That means we're not skipping over, we're not having any gaps, so it's working out okay for us to go from 0 to 4. When we do the range, we're looking now at the y values. So, and again, I got my light shine in this direction here, making a shadow here. Looks like my lowest y value is 1, my highest y value is 5, and even though I'm doubling up because I've got this left side going from 1 to 5, and I've got this right side going to 1 to 5, doesn't matter, we're just listing it once. So any side of the graph, if it gives you a y value, then just count it only once. Looks like we're including that y value of 1 here at that low spot, so I'll include it. And of course, we've got closed circles up there, so I will include them as well. So that's our example of domain and function, looking at it graphically. Here I've got a problem for you to do. So take a moment, hit pause, and identify which of these is the correct answer for the range of this graph. Okay, hopefully you got an answer. Hey, remember, range is the y value. So right away, these two don't work. Oh, scratch them out. They're not going to work for us. And so the question is, we're going from 0 to 1. So 0 to, 100. And it looks like we're picking up the 100. We're picking up the 0 because the golf ball is going to hit the ground again and the height is 0. So it looks like I want to include, so I'm going to take G as my answer here. Okay, so going from 0 to 100 in the y direction, we're doing the y values here, and we're including the high and low points there. Let's try it again. Take a moment, figure out which one is, this time, the domain. Okay, once again, we're looking for domain, so that means that's the x value. These two answers are y values, so let's get rid of them. And it looks like the farthest left point here is at -1. The farthest right point here is at 5. Takes everybody in between. We've got the closed circles there, so that means include. So I am going to take A as my answer here, going from -1 to 5 and including the -1 and 5. So that's kind of what I'm working on there. Okay, let's go to the next example. Okay, take a moment and answer the question, what is the range? All right, with range, remember we're doing the y values. So all these things with x's, get rid of them. These are only two options that we have to play with are these two right here. And so let's kind of take a look at what's happening to our y values. Looks like our lowest y value here is at 0 and our highest y value is here at 9. So I'll be taking everything between 0 and 9, including the 0 and 9 because these are closed brackets and I'm assuming there it's touching there at 0. So I'm going to go with D as my final answer on this one. Okay, let's try it again. This time we're looking for the domain. So take a moment, find the domain. Okay, once again, domain. We're looking at the x values. So sorry, C and A, you're not part of my answer. Now, one of the catches here is that I'm seeing an open circle right over here on the left-hand side and a closed circle on the right side. So we got to be careful of that. Looks like our the farthest left x value looks to be -2. The farthest right value is looking to be a 6. So we're going between -2 and 6, but not including the -2. So looks like this is the D is our answer right here. D is our answer. It's goes to -2 but does not include it, but we include the 6 because of how the open and closed circles at those endpoints. All right, give it a try for finding the range. Okay, we're looking for range. We're looking for y values. Once again, we can cross some things out really quickly because we don't want x's this time. All right, our lowest y value looks to be here at -4. Our highest y value looks to be here at 2, but notice that's an open circle there, so we do not want to include the 2. We'll take the -4, and that's why we'll take answer C here. It includes the -4, does not include the 2, and takes everybody in between. All right, so this time, take a moment, figure out what's the domain and range of this weird looking guy. Okay, for our domain, that's the x's. Looks like our farthest left x is -5, but open circle means do not include it. So we're going to go -5, don't include it. And then farthest right, looks like we're taking all the x's in between. There's no gaps, no holes, no spaces in there. So it looks like our farthest right x is 5. So we're going to go all the way to 5. It's got a closed circle there, so that's indicating we want to include the 5. Now when we're playing with the range, looks like the lowest y value that we use to make the graph is a -2. So the lowest y value is -2, and I'm going to include it because of this right here and this part right here. And you might be going like, dude, wait a minute, wait a minute. There's an open circle over here on the left-hand side. Doesn't that mean to exclude it? Well, wait a minute. The question is, when we're doing range and domain, is what are we using to make the graph? Because this side is over here saying, I don't need the -2, but these two parts of the graph over here saying, I need the -2. So to make this graph, we do need the -2, even though this far left side doesn't want it. But because this does, we're going to use it, we're going to include it. And then I'm going to stop here at 2. That's the highest y value. So it looks like we're going between -2 and 2. And if you want to do it with the inequalities, we can use that format as well, just to match up. That would have been -5 with a parentheses and a 5 with a square bracket. Now I'm consistent, got both answers. Okay, so next thing I'm going to do here is I'm going to do a piecewise function. That'll be on my next video. So I'm going to take a moment, going to pause and come back to you in part B. Thanks for watching.